At the end of each month, Bob invests $120 into an account earning a 6% annual rate compounded monthly. And then in Part A, we want to know what is the value of Bob's account after 5 years. So this is an example of an annuity. What distinguishes this from the compound interest problems that we've looked at so far is that we have Bob is making regular payments into the account, one payment at the end of every month. Previously in Section 3.2, the problems we looked at only involved one payment that was made right from the beginning, and then that was just allowed to sit there and collect interest. Now we're making regular payments into the account. Okay, so for all of these annuity problems, I would recommend starting out by identifying all the variables. If you look at the formula provided for annuities, you'll find the following variables: PV, or present value, FV, or future value, PMT, or payment, M, which is has the same meaning that it did in the compound interest problems, R, and I, again, which mean the same thing as with the compound interest problems, and then also T and N. Okay, so dissecting this problem, it says that payments occur at the end of each month, and interest is also compounded monthly. So M in this case is 12. The size of the payments every month is $120, and the annual interest rate is 0.06 or 6%. Dividing by 12 gives me the monthly interest rate, which is 0.005. And we want to know the value of the account after 5 years, which would be 60 months. That leaves us with two variables left over, PV and FV. FV is what we want to solve for. That's the future value, or the amount, the value of the account after the 5 years. So the question is then, what is PV? Well, unless we're told otherwise, we're assuming that we're always starting out with an empty account, which means present value, or PV, is 0. Okay, so the formula for an annuity in which the payment increases the overall balance, as in this example, is the following. FV equals PV times 1 plus I raised to N plus PMT times 1 plus I to the N minus 1 divided by I. So plugging in the variables that we have in our specific problem, future value is equal to, okay, now PV in this case is 0. In fact, every problem we deal with in this section is going to involve starting out with an empty account, and so the PV is 0. That's nice, because that means we don't have to deal with this term at all. Okay, payment here is 120. And then I multiply this by 1 plus I, so that's 1.005, that's 1 plus I, raised to N, so I raise that to the 60th power, and then I subtract 1 off, divided by 0.005. Okay, so the first thing I'm going to do is I'm going to calculate all of this business at once in the calculator. So really, I'm going to do this in a couple of steps. I calculate the 1.005, and I raise that to the 60th power. Then I subtract 1 from that, and then I divide by the 0.05. And this gives me 120 times 69.77003, or 8,372.40. Okay, so this is how much Bob has in his account at the end of 5 years. In Part B, the problem asks us to determine how much Bob invested over the course of the 5 years. How much of his own money did he put into the account? I encourage you to maybe pause the video for a moment to think about this, to see if you can figure it out. Once you figure it out, the actual calculation is not hard. Basically, the idea is Bob makes 60 payments where he deposits his own money in the account, and these payments are $120 apiece. So, the total of Bob's deposits would be equal to 120, that's the size of the deposit, times 60, that's the number of deposits he makes. So $7,200 is the total amount that Bob deposits of his own money. Okay, well, part C asks, how much interest did Bob earn over the course of the 5 years? Well, you can see that $7,200 is how much of his own money he put in over the 5 years. But at the end of the 5 years, he ended up with $8,372.40. So he put in one amount, and the other amount is how much he had at the end of the 5 years. The difference between those two values has to be the amount of interest that Bob earned. So, the interest that Bob earned over the course of the 5 years is equal to the balance at the end of the 5 years minus the amount of his own money that he actually put in. So performing that calculation, I end up with $1,172.40. That is the amount of interest Bob earned over the course of the 5 years.